So today we're going to talk about the data science process. And in particular, we'll give historical notes on the KDD process, the CRISP-DM process, big data and data science, and their relationships to data mining and machine learning. And I'll go through an example of the knowledge discovery process. Okay, so let's start with some historical notes. So the term big data was coined by these two astronomers in 1997. So it's kind of an old term that got a bit hyped up a few years ago after the CCC white papers on big data came out. Now, I'm showing you here the CCC big data pipeline from the white paper in 2012. It's nice. It's a nice effort to formalize the scientific process that goes into discovering knowledge from data. Right? It's not just data mining. Data mining, there's a lot more steps to it. In fact, data mining is actually in here. It's actually in the 4th step out of 5. And the major steps in the analysis of big data are shown in this flow at the top, but then these are big data needs that make these tasks up here challenging. So let me go through the 5 steps. So perhaps first you have to go through a process of actually obtaining the data. And perhaps that involves recording how users behave on different websites or something. So you have to write a script to collect the data properly. And then the second step is extraction or cleaning or annotation, where you try to reduce the noise a bit and get rid of the data you don't directly need. Or if you're working with free text that's easy to annotate, you might be able to turn it into a structured table. So basically at this step, you're turning the data from what is potentially a pile of rubbish into something you might actually be able to work with. Now this third step, which is integration, aggregation, and representation, you're going to set up the data in a way that's directly conducive to data mining. So all the text documents are going to be linked properly to other structured tables, and you've got one central database where all that information is stored nice and neatly. And then this is the analysis and modeling step, which is where all of the great machine learning and data mining takes place. And then the interpretation step is where at the end you see what you've got and you really interpret it. Okay, so this is the big data pipeline. And now I'm going to show you another separate big data pipeline constructed by a separate group of people at a separate time. And this second group of people, these are also people trying to formalize the process of knowledge discovery. You ready? Okay, so this is what's called the KDD process, Knowledge Discovery in Databases, which was published way back in 1996. And it has these 5 steps. So selection, preprocessing, transformation, data mining, interpretation. Does it look familiar? It should, because these are the same 5 steps that appeared on the previous slide. Right? Same exact steps. So you're probably not surprised. You say, okay, so what? 2 groups of people, they come up with the same diagram. But look, this diagram is from 1996, right? And an interesting piece of this whole story is that the CCC people in 2012, they actually didn't cite the original KDD paper. So it's actually possible that they didn't know about each other. 2 completely separate groups of people coming together and producing exactly the same thing several years apart. Perhaps there's something fundamental about this process. Maybe it's like an important number, like pi or the golden ratio or something. Maybe this is sort of a universal process that maybe anyone who works with data will discover. Anyway, so this is the KDD process. Now it seems so abstract, but there might actually be something fundamental about this. By the way, reading both of these articles is really inspiring. One thing I want to point out again is that in both cases, data mining is only a part of this process. One part, not all of it. Now, granted, it's like the climax of a story, but like any story, the setup of the story really makes the whole thing work. Now, KDD wasn't the only game in town before the CCC white papers. So this is CRISP-DM, the cross-industry standard process for data mining. And these guys were really serious about formalizing the knowledge discovery process. They wrote a 77-page manual on how to do this stuff. And I actually like CRISP-DM's process the best because it includes business understanding and data understanding, which I think are important. And I also love all of these backward arrows that kind of show, how many iterations you realistically do within this process on a regular basis. So anyway, this is the process that I tend to think of when I think of the data science process. So just to summarize, the stages are basically the same no matter who invents or reinvents this knowledge discovery, data mining, big data, or data science process. You may not always need all the stages. And data science is an iterative process. There's backward arrows on most of those process diagrams, and those backward arrows are really part of the process. You never end up doing it just once. So let's go through an example of the knowledge discovery process. And in particular, I'm going to walk you through an example that I worked on, which is the process of predicting power failures in Manhattan. So the motivation of this example is that in New York City, the peak demand for electricity is rising, but the infrastructure that's supporting New York actually dates back to the 1880s from the time of Thomas Edison. And power failures occur in New York fairly often, enough to do statistics on, and they're actually somewhat expensive to repair. So our goal was to figure out how to prioritize which manholes were going to be inspected in order to optimally reduce the number of manhole events in the future. And a manhole event is either a fire or an explosion or a smoking manhole. And this is a real problem. This is something I actually worked on. So let's go through the stages in the knowledge discovery process. And of course, so there, opportunity assessment and business understanding. This is CRISP-DM's process. Data understanding and data acquisition, preparation and cleaning, model building, and policy construction. And if you want the 77-page description, you're welcome to look at the CRISP-DM manual. Okay, so evaluation and then model deployment. Okay, so so what do you really want to accomplish, right? In opportunity assessment and business understanding, the first step, what do you really want to accomplish? What are your constraints? What are your risks? And how are you going to evaluate the quality of the results? And these goals are concrete, right? We can form concrete assessments of how well we did with these tasks. So for manhole events, our goal was just generally predict fires and explosions before they occur. And so we tried to make that more precise. So the first goal was to assess predictive accuracy for predicting manhole events in the year before they happen. So we specified a particular time frame, and we defined very carefully what a manhole event was. And then the second goal was to create a cost-benefit analysis for the inspection policies, these new inspection policies that take into account the cost of doing the inspection, but also the cost of a fire. So these trade off with each other, because if you do more inspections, you have less fires. And if you do less inspections, you have more fires. And that will help you optimally determine how often the manholes need to be inspected. So this is the second step, data understanding and data acquisition. Now, the data that we had were trouble tickets, which are free text documents that were typed by the dispatchers in the power company while they were directing the action of what to do about the problem. And they were typing this all in while this was going on. We had also a lot of records of information about the manholes, where they were located and what type of cover they had, and other basic information about the manholes, whether it was a manhole proper or a service box. We also had a lot of records of information about underground cables. And one major challenge in all of this was that the cable data was not matched to the manhole data. We had to do it ourselves. And so what happened was when we tried to match up which cables went with which manholes, we actually lost about half the cable records in the process. So we had to do a lot of data cleaning to try to do that data integration properly. And then we also had electrical shock information tables and extra information about these serious events. There was a separate table that had that information. And we had inspection reports and also vented cover data, which manholes had special vented covers and which ones had solid covers. Now, the inspection report data was interesting because the inspection program was relatively new. They weren't inspecting manholes up until the start of when almost the start of when we started working on this project. So this was brand new data that we were working with, and it was its quality was evolving over time. Now, you probably have heard of the 4 V's of big data. So velocity, variety, and volume and veracity. So 2 of those, variety and veracity, those are challenges that we had to face, right? There was a huge variety of different data. It was in all different formats. And veracity also was an issue. So veracity means how trustworthy is the data. And we had different data with different levels of trustworthiness. So we had to be very careful about how exactly we used the data and made sure that we depended on the right data and didn't depend too much on the wrong data. So that just boils down to the question, well, how do you know what data that you should trust? Okay, so the next step in the process is data cleaning and transformation. And obviously, sometimes that is actually 99% of the work. The machine learning gets to take all the credit, but actually the data cleaning it's a huge amount of work. So before this step, right, you might have a giant pile of garbage, and you're supposed to turn it into gold. So for us, we had to turn all of the free text into structured information. We had trouble tickets, and we had to turn each trouble ticket into a vector that looks something like this. So it's a vector is a collection of numbers. And we had to turn it into something that looked like this. So was the trouble ticket representing a serious event or a less serious event, or was it just not an event? What year, month, day was it in? What manholes were involved in it? And all this other kind of information. And then, again, as I mentioned, trying to integrate the tables is particularly difficult. So just to try to join the manholes to what cables they fit into, we just lost half the cable records. And so we had to do a lot of work trying to make sure the integrity of that table join was good. Okay, so I like to think of the knowledge discovery process sort of like alchemy. Right? Alchemy is where you try to turn lead into gold, except that alchemy doesn't work, but data often does. And business understanding, it's like, am I really going to get gold out of this? Right? What constitutes gold here? And data understanding is sort of like, what are my raw materials that I'm going to collect? And then data preparation over here, that one is like, that's an important step. That's where you purify all the raw ingredients and you get rid of all the junk and the contaminants. And then modeling, the modeling step, that's where you actually do the transformation of the raw ingredients into gold. And that's why people are obsessed with it. And that's why other people think it's magic. But really, as long as you did the data processing right, this step is generally pretty easy. And it does work like magic. But you'll see it's definitely not magic. Now, for the evaluation step, that's where the appraiser comes and tells you how much the gold is worth. And then, of course, deployment is where the whole village comes to buy your gold. Okay, back to the modeling step. Now, predictive modeling means machine learning or statistical modeling. It doesn't necessarily mean prediction in the future time-wise, right? It could just mean prediction of a new circumstance that you haven't seen before. Now, if your goal is to answer yes or no questions, then this is classification. So, for instance, if you're asking questions like, will a manhole explode next year? Yes or no, right? This is a classification problem. If you want to predict a numerical value, this is regression. Like if you want to predict how many bicycles are going to be rented next year, right? That's a regression problem. And then if you want to group observations into similar looking groups, that's actually a clustering problem. If you want to recommend someone an item, like a book or a movie or a product, based on ratings from other customers, then this is a recommendation system. And I should mention to you that there are many, many other machine learning problems out there. I've just told you 4 important categories of machine learning problems, but there are many, many other ones. Okay, so policy construction. How's your model going to be used to change policy? So for manholes, how should we recommend changing the inspection policy based on our model? How can we construct something that's actionable? So for example, let's consider using social media and customer purchase data to determine customer participation if Starbucks, say, moves into new city. Right? After the model's created, how do you do that optimization where the shops are located? How big they should be and where the warehouses are located, right? That's an optimization problem. So this is a policy construction problem. So model building, that part, the last part, that's predictive. Policy construction is prescriptive. So policy construction usually involves solving some complicated optimization problem. Evaluation. So how do you measure the quality of the result? Right? Evaluation can be difficult if the data don't actually provide ground truth. But luckily for the manhole problem, we were working with engineers at Con Edison, and what they did was they withheld a lot of high-quality recent data so they could use it to test our predictive model to see whether we had predicted events that happened between when the model was built and when they actually happened. And that's how they knew that they could trust us, because this was a blind test. Okay, so deployment is the last step. This is like, you know, hey, I turned lead into gold. And I will warn you that, you know, getting a working proof of concept deployed, it actually stops, I would say, 95% of projects, because it's like, you know, hey, I turned lead into gold, and the reaction is, well, that's nice. You know, you need to actually get it implemented. So my suggestion is just don't even bother doing it in the first place if nobody plans to deploy it, right? So unless, of course, it's actually fun. So you should, you know, you should keep a realistic timeline in mind. And then I think also you should add several months to that timeline, because, you know, the goals might change, the data itself might change, the data might change as a reaction to your new policy. You might observe something that you didn't expect, and you need to put it in, and so on and so forth. And while the model is deployed, it will need to be updated and improved. Just keep that in mind when you're doing this. It's not a one-shot thing. You're always going to need to go and follow those backward arrows back to the beginning and update things and improve things. Okay, so as I mentioned, knowledge discovery is an iterative process. You know, you got to do things over and over again. And it might be helpful to kind of keep pieces of code around to have for the whole process, so that you can run things through the process without having to look for little bits of code that you wrote a couple of years ago. Now, at least if you have this outline, it sort of helps you figure out what to charge people for your services if you're like a contractor or something. It's not like you can just charge them for doing some modeling, right? You actually have to charge them for all parts of this knowledge discovery process and the iterations that you're going to do to continue to fix up the system and keep it updated and get it deployed. So a proposal to work might actually include sort of each of these steps in the process within the proposal to actually do the work. All right, so let's summarize. There have been several attempts to make the process of discovering knowledge scientific. And those attempts are called the KDD process, the CRISP-DM process, and the CCC Big Data Pipeline. They all have very similar steps, and data mining is only one of those steps. However, it is an important one.